I would like to talk now about operators and making decisions. Some of the stuff that I'm going to be covering about the operators for some of you guys is going to be pretty mundane. You're going to say, yeah, I've heard all of this before. And some of you other folks may be coming from C-based languages that are loosely typed, and those languages pretty much cover you when you make a mistake. The compiler goes, oh, I know what he's trying to do, and fixes life. So I'm going to create a couple of scenarios that result in strange results and give you an idea of what all that looks like when things go wrong. All right. So the first thing I'm going to do here is get rid of this comment line, or at least just this comment, and I'm going to pop in a variable there. Int, let's call it x, is equal to 10. Int y is equal to 20, and make the code look pretty, right? And don't forget those semicolons. I'm always forgetting them. Okay, so int z is equal to x divided by y. We know what the divide symbol does, so I shouldn't have to explain that. We know what the times symbol does and all of that. So here we go. I'm going to come down here to the log, and I'll say z var z, put a space, and let's put a placeholder in there. Since I'm dealing with an int, I'm going to go ahead and put in integer. You could go d or whatever for your format code. So we'll put that in there, put in z, and it looks like that's going to probably work. So let's run this. And it comes back and it says, there's the class that I'm running, var z is 0. There's my nice little message. Let's create a little space around it so that it's a little bit easier to isolate the output. So try that again, and there it is. Var z is equal to 0. Okay. Well, that's not too bad, except that in truth z isn't equal to 0. Z is equal to 0.5. So one common mistake is, just make this float, and we should be great in River City. So push the play button, and we see that var c now is 4144. That's exciting. That doesn't make any sense. And the person will go, well, yeah, that's right, because z is a float, and I forgot to fix the format code. No biggie. So we'll go ahead and turn that into a float and pick that. And now var z is 0. I know var z isn't 0. Well, what we're performing here is integer division. We're dividing an integer by an integer, and the result's going to end up truncating anything to the right of the decimal point. So one of these critters has to be turned into a float as well. So we will cast it. Float. Just like so. And we'll hit the play button. And there it is. Finally, var z is showing 0.5 with lots of zeros. And I'm not sure that I want lots of zeros. Let's say that I'm going to go with 2 zeros. So I'm going to go 0, because I don't care about the number of actual significant digits. And I'm going to go 2. So I am going to have a precision of 2 on this critter. Hit the play, or hit the run button, and there it is. Z is 0.50. The next situation that I think bears investigation or bears revisiting is the modulus operator. Modulus operator is pretty straightforward. What we can do is we can say z, actually let's go up here. I'll turn this back to an int, because modulus operators have to use integers, okay? And I'm going to say int z is equal to x modulus y, and I'm going to make y be, say, 8. Okay, so if I try to divide 8 into 10, what will the remainder be? I chose a number that should be pretty easy for you guys. Hit the play button, it comes back and it gives me all this nasty, because once again, we forgot to get the right formatting code in there. Sure glad that happened. Okay, so we're going to get rid of that, turn this into an I or a D, and hit the run button, and there it is. Var z is 2. So if I try to divide 8 into 10, I'm going to end up with a remainder of 2. Now this is a really, really cool thing, because let's say that I have a number. Let's see, how can I best explain this? How can I best explain this? If I have, oh, I don't know. I have a list of numbers, or I have, 1, 2, 3, 4, 5, 6, 7, and then it repeats again. 1, 2, 3, 4, 5, 6, 7, and then repeats again. 1, 2, 3, 4, 5, 6, 7, or rather 0 through 7. My question is, in that situation, I'm going to have this big old giant column of numbers, and I decide to take the 45th row. If I take the 45th row, what number will appear? Okay, so in other words, let's go ahead and put in some comments to help us out. I have 1 or 0, 1, 2, 3, ... until I get to, say, 7. Okay? Now, I have done that repeatedly 10,000 times. Okay? The question is, on the, 356th row, what will the number actually be? Will it be a 0, a 1, a 2, a 3, 4, 5, 6, or a 7? Okay, so I'll just put a little question mark in there, and I hope that makes sense to you. So what you do is you say int x, right there, is 356. And then you say y is the maximum value of the numbers that those rows will ever be. Because remember, we start from 0 all the way down through 7. So that'll be the maximum value that those rows will ever be. And let's go ahead and hit the play button or the run button. And it comes back and it says that it's 6. So if I was to go down to the 356th row of that column of repeating digits 0 through 7, I would find that this row contains the number 7. This is really, really an important concept, because if you want to create what's called a circular queue, this is going to be the approach that you take. I'll give you the details for all of that later on when we're actually programming iOS applications. But for right now, this gives you a kind of another way of looking at modulus. I'm hoping that you were able to wrap your head around it.